And here we are at the final step of the audit sampling process, and that is, of course, evaluating the audit sampling results. Now, needless to say, this is a very crucial step, as this is where we, as auditors, make the decision of whether the financial statements are fairly presented and whether the controls of the client are reliable. Depending on whether, of course, we're performing substantive test or test of controls. So, having said that, we have to point out that in terms of evaluating the results, there will be a slight difference as to whether or based on whether the auditor is using statistical or non-statistical sampling and whether the auditor is performing tests of controls or substantive tests. Now, in order for us to discuss this phase in the audit sampling process, what better way than to do it via an illustration? So let's have this first example, assuming the auditor is performing tests of controls. So an auditor is testing controls over the authorization of purchase orders in the company. So the characteristic that the auditor wished to test is the authorization of the purchase orders. Therefore, if the auditor finds a purchase order that is not authorized, then the auditor will consider that one as a deviation. Now, the auditor uses a sample size of 90 purchase orders to evaluate the effectiveness of the control. Now, if the auditor is using a statistical sampling approach, then we could already assume that the sample size of 90, is computed by the auditor using perhaps a sample size calculator or using a sample size table. Now, here are the pertinent facts of our illustration. So, the sampling method used is random sampling. Again, our sample size is 90 purchase orders. The expected deviation rate, and right about here, we remember that if it's expected, then it will have a direct relationship to sample size. So the higher is the expected deviation rate, the bigger is our sample size. In this case, the auditor has set it at 2%. In terms of the tolerable deviation rate, now the tolerable deviation rate has an inverse relationship to sample size. Okay, in this case, the tolerable deviation rate is set at 5%. Similarly, the acceptable risk of over-reliance, our ARO or our acceptable type 2 risk, is also set by the auditor at 5%. Both tolerable deviation rate and acceptable risk of over-reliance has an inverse relationship to your sample size. Now, out of the 90 sample purchase orders, the auditor finds two deviations. Let us now illustrate what our evaluation phase would look like if the auditor is using statistical sampling. So the first thing we have to do is to compute the sample deviation rate. So when we talk about the sample deviation rate, we're referring to the number of deviations found in the sample. Based on our given problem, well, our number of deviations or the number of deviations we have actually found is 2, and the sample size is 90. Therefore, to compute for the sample deviation rate, simply 2 over 90, that will give us a sample deviation rate of 2.22%. Okay, after we have computed the sample deviation rate, we will now proceed to the second step, which is determining the upper precision limit. Now, the upper precision limit is a consideration that we make whenever we are using statistical sampling. Okay, and the upper precision limit is determined by using statistical tables. And the important information that we need to get in order for us to use the statistical table would be the number of deviations, the sample size, and our arrow or the acceptable risk of over reliance. So let me show you an example of this statistical table. Of course, this could also be present in a statistical software, okay? But I'm presenting to you here the sample statistical table using 5% risk of over reliance, okay? Now remember that our sample size is 90 and the number of deviations actually found in the sample is 2. So using this statistical table, we will be able to see that our upper precision limit is set at 6.9%. So yes, we do not actually compute the upper precision limit. We determine it using a statistical table or a statistical software. This is the reason why in our Philippine CPA licensure examinations, we do not usually, or our examinees are not usually asked to evaluate using a statistical sampling approach, mainly because we are not given access to the statistical software, nor is the statistical table provided. But just in case that they will be providing you with the statistical table, so this is how we're going to use it. So again, pick the statistical table that corresponds to your arrow or your acceptable risk of over-reliance, in this case 5%, and then just choose the sample size and the number of deviations, and voila, you will have your upper precision limit. So in the case of our illustration, our upper precision limit is 6.9%. So what have we done so far? We have computed the sample deviation rate. We have determined the upper precision limit. We will now compute the allowance for sampling risk. So if you think about the allowance for sampling risk, you're basically looking at that cushion or that allowance that the auditor has, that whatever is the result of the sample may not be the true state of the population. So to compute for the allowance for sampling risk, in not in so using statistical sampling, sorry, in using statistical sampling, our allowance for sampling risk is computed as the upper precision limit less the sample deviation rate. That's why we had to start with these two. So in our case, the upper precision limit is 6.9 and our sample deviation rate is 2.22. Therefore, our allowance for sampling risk is 4.68. So the higher the allowance for sampling risk is, the more comfortable the auditor is that the results of the population represent, the results of the sample rather represent that of the population. The lower is the allowance for sampling risk, the more uncertain we are about the results of our sampling. So the auditor would be happy to see a higher allowance for sampling risk. Now, having determined those things, we now make a conclusion. So in the case of statistical sampling, the conclusion of the auditor will be based upon the comparison of the upper precision limit and the tolerable deviation rate. So in our case, the upper precision limit is 6.9, but the auditor is only willing to tolerate 5%. It's kind of like saying, based on the results of the statistical sampling approach that the auditor used, it was found out that the actual, if we can use that word, of course, it's not the actual, but then the achieved, okay, the achieved precision limit is actually 6.9, but we are only willing to accept 5. Okay, so the achieved limit is 6.9. We are only willing to accept 5. Therefore, the conclusion of the auditor would be that, well, it would seem that the controls are not reliable because it has exceeded what you are willing to tolerate. Now, in this case, the auditor has the option to, number one, reconsider ARO and TER, but the auditor must do this with caution because the first option is for the auditor to recalibrate his or her initial expectations based on professional judgment. So, like what we have mentioned, we have to make sure that this is done with caution and that the auditor is not merely changing, okay, the ARO and the TER just to give a result that it is reliable, that the controls are reliable. So this must be done with caution. Another option that the auditor can consider is to expand the sample size, meaning to say test more units. Or the auditor may assess control risk as more than high, ergo that controls are not effective. Or assess control risk as high. No, ergo the controls are not effective. So when the auditor sees results like this, where the upper precision limit exceeds the tolerable deviation rate, the most likely conclusion of the auditor is that the controls are weak or are not effective and so therefore should not be relied upon. However, as we have pointed out, the auditor can actually consider either reconsidering ARO and TER or expanding sample size before coming up with that decision. This is what's going to happen if the auditor uses statistical sampling plan. Now, what if the auditor is using a non-statistical sampling approach? Well, the first step will be the same in that, we have to compute the sample deviation rate. The formula is the same, just get the number of deviations over the sample size. In a non-statistical sampling approach, we are not going to determine the upper precision limit because if it's non-statistical, the auditor does not quantify the risk. That's why if you notice in number 4, the acceptable risk of over-reliance is not specifically set. In fact, in some instances, the expected deviation rate is also not specifically set in the case of non-statistical sampling approach. And because of this, we cannot determine the upper precision limit. So what we are going to do is to simply compute the allowance for sampling risk. And because we do not have an upper precision limit, Our allowance for sampling risk will simply be the tolerable deviation rate less the sample deviation rate. And I think it is precisely this formula that will allow us to appreciate the role of the allowance for sampling risk. Because if you can imagine, the tolerable deviation rate is kind of like your threshold, right? It's your limit, it's your threshold. And then the sample deviation rate is what you have actually found. So the bigger your sample deviation rate is, the closer it becomes to your tolerable deviation rate. And the closer it is to your tolerable deviation rate, the scarier it is for the auditor. This is what we mean when we say the auditor's level of comfort with regards the results of the sampling can be reflected in a larger allowance for sampling risk. Okay, so that being said, let us now compute our allowance for sampling risk using non-statistical sampling. We simply take our tolerable deviation rate, which is 5%, deduct from there our sample deviation rate of 2.22%, we get our allowance for sampling risk of 2.78%. So having computed that, by the way, allowance for sampling risk may also be estimated by the auditor if the auditor is using a non-statistical sampling. Okay, so meaning to say it's possible for the auditor to simply estimate or set an allowance for sampling risk if it's non-statistical. All right, so now we get to make the conclusion. So we have already computed our allowance for sampling risk. In the case of non-statistical sampling, well, our life is a little bit easier as we will make a conclusion simply basing on the tolerable deviation rate and the sample deviation rate. So imagine this. You're willing to tolerate up to 5% deviation, but the sample showed you only a 2.22% deviation. So you're willing to tolerate up to 5, and you only saw 2.22. So in this case, since the sample deviation rate did not exceed the tolerable deviation rate, you may conclude that control risk may be assessed at less than high, ergo the controls are effective and may be relied upon. You would perhaps notice that we have used the same illustration using statistical sampling and non-statistical sampling. And it just so happened that the two different approaches yielded opposing conclusions. When we used statistical sampling plan a while back, the conclusion was to not rely on the controls. But now that we're using a non-statistical sampling, the conclusion is that the controls may be relied upon. So this is what we mean when we say this is sampling risk, unless you test the entire population. But in the case of test of controls, we simply cannot test the entire population. However, do take note that it is very possible for the results of a non-statistical sampling plan to mirror or be the same as the results of a statistical sampling plan. Okay, it's possible. It's highly likely. Okay, it's just so happened in our illustration, it is not. So this is test of controls. All right. Now, I know you're also excited to illustrate evaluation of results using substantive tests. So let's use this one as our example. An auditor is performing substantive tests on accounts receivable to verify their existence and valuation. So we already know what is the assertion being tested, and this assertion will eventually lead you to the decision of which population is considered appropriate. Okay, now the auditor selects a sample of 2,000 customer accounts receivable balances from a total population of 4,800 accounts. So, in terms of the number of customers, we have a total of 4,800. In terms of the sample size, we have 2,000 customers. The population book value is 380,000, while the sample book value is 159,960. So, of course, when we refer to the book value, we're referring to the amount actually reflected in the books of the client. Now, the auditor finds a total misstatement of 8,600 in the sample. Okay, so in order to simplify things for us, let's try to open up this table where we will plug in all of our given information. So we know that the book value, of course, the book value will be in pesos, is 380,000 for the population. The sample size book value is 159,960. The number of customers, 4,800 for the population, 2,000 for our sample size. The amount of misstatements we do not know yet, for that we do not know the amount of misstatements in the entire population simply because we are not testing the entire population. What we do know is that the sample that we got is overstated by 8,600. Okay, that means that when we performed our testing, when we performed our examination of the accounts receivable account, the audited value of the sample was 151,360. So if you can imagine, if we sent out confirmation requests to the customers, when they returned their replies to us and when we footed all of their confirmations, the amount only totaled 151,360. But the books, the list, okay, of our client showed 159,960. So that means that the sample, okay, the sample book value is overstated. It is overstated because it's more than the audited value. It's overstated by 8,600. Now, in terms of substantive testing, if the auditor uses a statistical approach, then similar to our test of controls where we have to determine an upper precision limit, under statistical approach for substantive testing, then the auditor will also have to determine a factor that it will apply, right, to the book value or the audited value. Okay, but what we're going to illustrate here, because again that will make use of statistical tables and the statistical software, so what we're going to illustrate here are the different ways by which the auditor will project the misstatement. So if you see there, the population has blank amounts for the amount of misstatements and audited value. That is what we are going to solve for. And then there are many different ways to solve for the projected misstatement as well as the audited value of the population. Let's start with what is called a ratio estimation. So under ratio estimation, as the term would suggest, we will come up with a ratio, okay, of the audited value versus the book value and use that one for the projection of the misstatements. So first step, we're going to compute for the ratio of the sample audited value to the sample book value. Our sample audited value is 151,360. Our book value is 159,960. That means we're able to come up with a ratio of 94.62%. Take note that it is less than 100% because the book value is overstated. That means in the grand scheme of things, we need to decrease the book value, okay, to make it the correct amount. So it's less than 100% because it's overstated. Now, the next step that we are going to do is to compute for the estimated audited value. Okay, so in this case, we've already determined it to be 94.62. So our ratio will now be multiplied by the population book value. Okay, so we have 0.9462 multiplied by 380,000. This will come up with an estimated population audited value of 359,556. So based on the ratio that we have found in the sample, we can now more or less estimate what would have been the audited value had we tested the entire population. So the audited value of the entire population is estimated to be 359,556. And from here, we can then determine what is our estimated population misstatement. But in this case, let's go through the determination first of the sample misstatement, which we already know to be 8,600 pesos anyway. Okay, so now that we have determined the sample misstatement, we can now determine the projected misstatement. So the projected misstatement will simply be the difference between our estimated audited value of the population and the book value. So it's kind of like saying, well, based on the ratio that we have found in the samples, it would appear that the audited value should be 359,556, but based on the books, it's 380,000. So therefore, to compute for the projected misstatement, our projected misstatement then is 20,444, which is an overstatement, okay, in the books. Again, we're saying it's an overstatement because of the results of our sample. Now, the 20,444 overstatement is what we will compare to our tolerable misstatement, which unfortunately is not provided in our illustration. Okay, but the idea is that you get the projected misstatement and then compare that with your tolerable misstatement. And if the projected misstatement exceeds the tolerable misstatement, so again, imagine the tolerable misstatement to be like your limit or your threshold. So if your projected misstatement already exceeds that, then that is an indication that the account is materially misstated. But similar to test of controls, if it goes closer to your tolerable misstatement or even exceeds your tolerable misstatement, the auditor then considers whether the auditor should examine additional units or perform additional procedures on the same assertion. Okay, a different procedure but testing the same assertion, or request the client to adjust. And if the client does not adjust, then this is now the time that the auditor will make a decision, will make a conclusion that the account is materially misstated. So again, I appeal to you to just like remember that what you're going to do is compare projected misstatement versus tolerable. Tolerable is what we are willing to accept. The moment it exceeds or the moment it comes close, equals or even exceeds tolerable misstatement, that can be an indication that the account is materially misstated. And so therefore, you may do these steps. Okay? Now, there is another projection technique that is called a difference estimation. Okay, a difference estimation approach in order to project the misstatements. Let's assume the same given information, but this time we are not going to start by computing the ratio because what we are using is a difference estimation. So, what we will do is we will start by computing for the average difference between the audited value, the sample audited value, and the sample book value. So, our sample audited value is 151,360 and it is made up of 2,000 accounts. Okay. Our sample book value is 159,960 and it is made up of 2,000 accounts as well because we are basing on the sample. That means our sample average audited value is 76. On the average, then it will be 76 pesos per customer, but the book value registers an average of 80. So again, just imagine. It's kind of like saying on the average, the customers have a balance of 80 pesos per customer per the books, but per the audit, it's only 76. Okay, so this will reveal a 4 peso an overstatement per unit. Okay, per unit. We have only tested 2,000 units, but there are a total of 4,800 units. So have you noticed the difference between the two? In the case of ratio estimation, what is computed is the ratio using the book value. I mean, using the values, audited value and book value. But in terms of difference estimation, what is used is the per unit, or in this case, the per customer. That is why ratio estimation is normally used if the auditor has reason to believe that the misstatements are attached more to the book value rather than the units. And we make use of difference estimation if we have reason to believe that the misstatements are attached more to the units, more to the per customer rather than the balance or the book value of the customer. So remember that, okay? So anyway, here in difference estimation, we have computed a 4 peso overstatement per customer. Let us now compute the projected misstatement. Well, we are saying, based on the results of the sample, each customer has an overstatement of 4 pesos. We have determined that using the 2000 sample size, but there are a total of 4800 customers. So meaning to say, if each customer is overstated by 4 pesos, then that means the total overstatement is 19,200. And again, this is what we will compare with our tolerable misstatement. If it exceeds, you know what to do. Okay. But then, let us not stop there. We have to determine what is our estimated population audited value. So I think you know what to do with this already. You have a book value of 380,000. Based on our projection, that is overstated by a total of 19,200. So simply deduct the overstatement from the book value. So that being said, we will come up with an estimated population audited value of 360,800. Okay. Now, I know I shouldn't be telling you this, but I can't help but remind you that our example is an overstatement. That's why we are deducting it. So if it's an understatement, then we have to add it, okay, to the book value. All right. The last process, not process, but the last option, okay, the last option that you have in determining the projected misstatement is by use of a mean per unit estimation. So mean per unit is normally useful when the information provided to you is not complete. Okay, it allows you to estimate, for example, what would have been the value of the population. So what we're simply going to do is multiply the average audited value by the number of items in the population. So remember a while back, we computed it at 76. Okay, so that was 151,360, the audited value, divided by the sample size of 2,000. So that's 76. So under mean per unit, mean means average. So we got the per unit balance of the customers. So there are 70, or there is a balance of 76 pesos per customer, and there are 4,800 customers. Therefore, our audited value is 364,800. Now, normally the mean per unit is used by the auditor when the population book value is unknown. So if we assume that we don't know the 380,000 as the population book value, then we can use mean per unit estimation to estimate the book value. So in this case, our estimated population audited value is 364,800. Now, assume that there is an allowance for sampling risk amounting to plus minus 40,000. If you're wondering how the 40,000 was arrived at, that's auditor judgment. Then our estimated population audited value would be in the range of 324,800 and 404,800. So this basically provides you with a range of reasonable audit value for the population. Again, this is normally used by the auditor when the book value is not known. So if the book value is not known, then the auditor will give a range between 324,800 and 404,800. That is using mean per unit estimation. All right. With that, thank you so very much for joining me in this lecture series about audit sampling. And as per usual, I hope to see all of you in the next one.